About one of the enablers that we talked about earlier. So it's gait recognition, so it's detecting your walking pattern. Okay, so we're looking at a reputation score computation. So smartphones are usually put in the owner's pocket for most of the day, and walking, this is also called gait analysis, can be used to implicitly authenticate users. We were looking at an unobtrusive way to authenticate users in addition to swiping your screen or entering a password. And some research has been done in the area of humanities, like on average men walk over 7,000 steps a day, women 5,000 steps a day. These are obviously distributed throughout the day. And if the phone is stolen, obviously some walking is probably involved, so therefore if it's feasible to detect that the walking pattern is different, we could perform some security measure like locking down the phone. Okay, but maybe a quick detection is necessary. So we're looking at some kind of biometrics which are using the sensors on the mobile phone. Obviously the mobile phone, modern smartphones are packed with sensors. Is it possible to use some of them to differentiate the walking pattern? Okay, and we call it the rightful user, the person who owns the phone, and differentiate from an imposter, someone who's taken the phone without permission, or is not the usual owner of the phone, as phones normally have one user. Okay, so how do we do this? We're using the accelerometer, okay, to identify the walking pattern and to differentiate between the imposter. This is a problem of detecting anomalies in a time series. Obviously, the accelerometer is time-stamped, and it's a semi-supervised approach. This is a machine learning approach. Semi-supervised, we say that the owner trains the phone. They have the phone, they tap the app, and they train it. Okay, and then testing data consists of normal data if the actual owner has the phone, or anomaly data if someone has stolen it. Okay, so again, we class the data as normal or anomaly, so it could be seen as anomaly detection as well. Okay, this is an example. The accelerometer has been used in a bit of research, quite a bit of research to perform gait analysis. The gyroscope has been used occasionally, but maybe the accelerometer. Okay, and obviously in modern smartphones the accelerometer has 3 axes, X, Y, Z. Okay, and here's an example of a trace. Blue is X, Y is red, and green is Z. Okay, I'm trying to think how many actual walks is that. Oh, you see here 1, 2, 3, 4, 5. 6 cycles. Okay. With the 3 axes of the accelerometer, you run into a problem of orientation. Okay, if you put your phone into the pocket upside down, you're going to have an incorrect model. Often the magnitude is taken. Okay, and if you look, this still produces a discernible signal. Okay, you can see the peaks here. Okay. And you can see the lower peaks here. Okay, and this is what we're doing. We're trying to model a normal pattern. Okay, and then detect when this is different. Okay, one problem we run into is that it requires some pre-processing. The Android app that collects the data, it takes as input a measurement of how often you want to collect the data, but that's just a suggestion. Okay, it does it when it can. So we actually have to linearly interpolate, and we do this to 25 Hertz. We found that to be useful and feasible. And then we use the magnitude vector, which has sometimes been used to avoid the orientation problem of putting it in the wrong way. And then we use a couple of machine learning techniques. We put the data into a phase space to keep the time element. And then we use a technique called kernel principal component analysis, similar to principal component analysis, if you've heard of this. And we can use this to construct a model of normal data, and then with this we can determine when the walking pattern has differed. Okay, so we've developed a smartphone app. We use a colleague of mine, Nick, from the University of Surrey, who made the face-to-face enabler. We can use this, and then just slot in our app which has two operations. We create a model of the normal data. The user provides a sample. And then we can switch it into security mode, which operates in the background. It uses one of the Google Play services. I don't know if you know this, which is activity recognition. I think it's been available for a couple of years. It can recognize the activity that's going on, whether it's walking, cycling, in a car,
running,
standing, running as well. Yeah, and tilting. It's the most common one, I think. Okay, so it checks when you're walking, and then it uses that data. Okay, and this fits into the security framework to try and determine whether the current user is the rightful user or an imposter. Okay, so using this, which is what we did this morning, Carmen trained it this morning with her walk, and then it recognized her as a rightful user. It posted this information to the context broker, and then when Carmen accessed the mobile environment app, that also accessed the context broker and said, is this person listed as a rightful user at this moment? And it said yes, and she was then allowed to open the app. Okay, and that's all.